All right, let's tackle one of those big, fancy words in programming that you absolutely need to know: polymorphism. Seriously, if you want to write clean, flexible code and, of course, ace that next technical interview, this concept is a must. So let's dive right in. Now, I get it. Polymorphism. The word itself just sounds complicated, doesn't it? Kind of like something you'd find buried deep in a super dense computer science textbook. But here's the thing, and this is the big secret. What if I told you that you're already an expert at it, that you use the core idea of polymorphism literally every single day of your life? So let's just forget about code for a second. I'm going to break this down with a real world analogy that will make everything just click. I want you to just think about, well, a person. It could be anyone, maybe even you. Now, you don't act the exact same way in every single situation, do you? Of course not. You adapt. For instance, in a classroom setting, that person might be a teacher, right? They're explaining ideas, guiding students. But then they go home, and that same person switches into the role of a parent, caring for their family in a completely different way. And later, when they meet up with their peers, they're a friend, totally relaxed and casual. See? It's the same person, but they exhibit totally different behaviors based on the context. And that's it. That is the fundamental idea behind polymorphism. You already get it. Okay, so let's tie this back to programming. The formal definition of polymorphism is one name, multiple forms. What that really means for us is one interface with multiple implementations. One name for an action, but many different ways that action can be carried out. For example, think about a function called draw. If you tell a circle object to draw, well, you get a circle. But if you call that exact same draw function on a rectangle object, you get a rectangle. Same name, completely different results. Now that you've got the main idea down, we need to get a little more specific. Polymorphism really comes in two main flavors, and you've got to know the difference. We've got compile time and runtime. So what's the deal with these two? Well, on one side, you have compile time polymorphism, which you'll often hear called function overloading. The decision on what code to run is made when the program is compiled. It's all figured out beforehand. But on the other side, you have runtime polymorphism, or method overriding. And this is where the real power is. Here, the decision happens while the program is actually running. This makes your code incredibly dynamic and flexible. Okay, that's enough theory. Let's actually see what this looks like in code, because this is where the concept really comes to life. First things first, we need a blueprint. In programming, we call this a base class. Think of it as our generic shape template. This template defines a rule. Any class that wants to be a shape must have a method called draw. So now we create our specific shapes. We make a circle class that inherits from shape. It follows the rule. It has a draw method, but it provides its own special instructions for how to draw a circle. Then we do the exact same thing for a rectangle. It also inherits from shape and provides its own unique version of draw up. And here is the magic, the crucial point. You can have a list of all these different shape objects, and when you call that one single draw method on each of them, you get different results every time. The circle draws a circle, and the rectangle draws a rectangle. One method call, many different behaviors. This all seems pretty clever, right? But why does it actually matter? What are the real-world, tangible benefits of doing things this way? Well, you get three huge wins. First up is flexibility. You can add a brand new shape, like a triangle, and you don't have to change a single line of your existing code that handles drawing. Second, code reusability. You write the code that calls draw just once, and it works for any shape you can dream of. And finally, it just makes for cleaner code. Your whole program becomes way more organized and so much easier to understand. All right, let's bring it all home. We need to boil this down to a rock-solid takeaway so you can not only use this concept, but absolutely nail it if it comes up in an interview. First, let's talk about a super common trap people fall into. They get confused between overloading and overriding. Just burn this into your brain. Overloading is decided at compile time, while overriding happens at runtime. If you can explain that difference, you're already ahead of the game. So the interviewer looks at you and they pop the question, can you explain polymorphism? What do you say? How do you give that perfect, concise answer? You look them right in the eye and say this: polymorphism means one interface, multiple implementations. It allows a single method name to have different behaviors depending on the specific object it's being called on. It's simple, it's accurate, and it shows you know exactly what you're talking about. And that's polymorphism. It's way more than just a fancy buzzword. It's a fundamental tool for writing fantastic code. If this helps things click for you, be sure to subscribe, because we're breaking down all the core ideas of object-oriented programming in this series. Thanks for watching, and I'll see you in the next one.